More or less. All right, this is a big group. Welcome, everybody. It's August 23rd. We're doing our lab meeting. We're in a new space. So this is Wallace 237A. When you guys make it to campus, stop by and see it. Everybody, so this, to the straight out the door is the new grad student space. So many people will have kind of desks out there. And then this room is kind of designated as a geospatial research space. Our lab, the Near Earth Imaging Lab, is going to be part of that space, but we are not the only people that are going to be using this space. Probably we're the only people that are going to be using the space for a while. But if there are other students that are doing geospatial research, then they're welcome as well, whether they're a part of NEAL or not. So let's just do a quick round of introductions. I think everybody knows me, so Tom Pingle. And then just let us know, like, where you are, where you're doing, department, year, and kind of just a quick research interest.
My name is Hudson. I'm a second-year master's student. I'm working with Dr. Pingle on geovisualization techniques in regards to VR and point clouds.
Hi, I'm Johanna. I don't actually remember who I met on one of the lab meetings I was part of, but I am working with Dr. Jeff Marion over in the forestry department. I am a first-year PhD student, but I've done my undergrad and master's here. So if you have any questions about Virginia Tech, I should be able to answer them. I am working in the field of recreation ecology, but I would like to, or I will be using some geospatial things to analyze stuff about camping impacts and trail impacts. So,
cool. Carly Aquilina, I'm in biological systems engineering under Cully Hessian, who has a drone with a LiDAR unit on it. I'm trying to use that data to assess like ecological indicators in riverscapes or like streams and rivers. Yeah, and I'm a second-year master's student. So.
Jimmy, I'm first-year master's student, and I guess I'm working with Tom Pingle and going for LiDAR and point cloud classification I'm aiming for geology stuff, but we'll see what happens.
Hi, my name is Jack Gonzalez. I'm working with Dr. Pingle as well. It's my first year master's, and I'm kind of interested in the coastal applications of photogrammetry and UAVs. And I'm also working with Anna Maria Bukvik on her coastal project, kind of like place attachment and risk perception and stuff like that.
Great. I'm Sam Cronny. I'm also under Dr. Pingle, first year master's student, and my broad research interests are kind of in the applications of remote sensing to identify hazards. So.
Very good. And the remote people?
Cool, I can go. I'm Riley Harris. I'm a second-year master's student working with Lisa Kennedy. Dr. Pingle has kindly agreed to be on my committee and has advised me in terms of using drones in my master's thesis to study a sensitive southern Appalachian grass bald. We're looking at sort of the spatiotemporal dynamics of vegetation there. Sorry I wasn't able to make the picnic last night. I had a kind of a conflict that I had to attend, but I would love to catch up with you guys at some point soon.
Cool. I'm Molly. I'm not entirely sure what year I am, hopefully second year master's student. And I'm working with Dr. Corinne Colivers and Dr. Golke over in the public health department. Dr. Pingle is also on my committee, and he's helping me with the Python portion of the project and the GIS portion. But we're looking at the impact of surface mine on birth defects in central Appalachia. And I'm also working on another kind of side project with Dr. Bill Carstensen, and we're trying to figure out how to extract individual treetops from LiDAR data.
Very good. All right. And I guess I'm kind of off to the side here, but you can see everybody. You can see everybody else, and you know what I look like, anyways. We've got a kind of a more of a fisheye camera, so we can try that, but the quality isn't as good. So, all right. I'm going to go ahead and get started. So Molly and Riley are planning on presenting, and anybody else?
I've got some slides in the Slack.
That's in. Okay. Sounds good. So, and Charlie?
Oh, okay.
Okay. And Johanna?
No.
All right, fantastic. And you guys are all.
I do have an update on what I presented like a couple weeks ago, though.
Okay, yeah, we can do that. It can be informal.
Just really informal. Yeah.
Yeah.
So Tom, Earl's gone now. He's got a job or something?
Yeah, Earl's gone. He's got a job. He's off surveying infrastructure in St. Louis. So he's kind of operating as a private contractor down there for a GIS company based in Chicago. And I think he's having a pretty good time. He said he's working 4 days a week, 10 hours a day, and then he's got to commute. His family lives in Rockford, Illinois, so it's a 4-hour drive or something between the two. So he goes down there and stays in a hotel, and then finds his way back. And Rob Kondratowicz has actually got a job as well. So that was last week. I don't know if he's posted it to Slack, but found a job working for a virtual reality company based in Chicago.
Oh,
So,
sweet.
super exciting for him. Okay, so we'll go ahead and get started here. Can you guys see the screen remotely?
Not at this point. Well, actually, yes. On one of my screens.
Yeah, I can see it.
Okay, all right, good. Okay, so since there's a lot of new people today, I thought it'd be worthwhile to just do a really quick introduction. So NEAL is the Near Earth Imaging Lab, and this is kind of a way to sort of collect the research that we're doing kind of surrounding a couple of major themes. So LiDAR, whether it's aerial, terrestrial, or drone-based photogrammetry, whether that's from drones or stuff mounted on a vehicle, or thanks to Johanna's idea, doing it on a big pole, which is super cool. Point cloud processing generally, so both LiDAR and photogrammetry are going to produce point clouds, and we're interested in sort of figuring out better ways to manipulate those and take those apart and visualize the data, process them algorithmically. We're using things like Cloud Compare, LAS tools, PDAL, and ArcGIS as well. We're into drones, whether that's flying stuff that has come out of a factory like DJI's stuff, or whether it's build your own. All of that stuff is kind of fair game. We don't get too deep into, well, we get into as much of that as we need to kind of do the job, but drones are kind of fun and interesting in their own right. So that's a good topic for us. 3D printing, so the lab 3D printer is sitting right here for now. Obviously the room space is still in flux a little bit, so I don't know where that's going to end up, but it may end up right there for all I know. And then kind of geovisualization broadly. And for those of you who haven't seen some of the 3D printed maps, I've got one of them brought in. We could put that together, put it on the conference table. I should have done that before you guys walked in the door. Maybe it would have made a good conversation piece, but we can do that later. Broadly speaking, we do a lot of GIS work. We have these kind of narrower particular interests, but hopefully we all have a pretty broad experience with GIS in general. And so, like for instance, Molly was working on stuff related to geolocation a little bit last time, stuff like that, figuring out better ways to do that kind of thing. That's of interest to us. So if you've got GIS related stuff, don't feel like you can't bring that stuff in the door. And then GIS programming, hopefully we're going to be a hub for helping people learn. We've got classes. I know many of you are taking Yang Xiao's R class this time around. My work tends to be pretty Python based, but anything goes. So I'm pretty familiar, just so you guys know, I'm pretty familiar with Java, JavaScript, and MATLAB are kind of primary languages for me. And then I know a good bit of a few other things. I know a little bit of R, but I'm not great at it. But once you know a couple of these really well, you kind of know how it works. So hopefully we can kind of be a good resource for the department and the college for geospatial programming. So if people have questions, they can kind of come to us. One of the things that I finally got done that I've been working on for a long time is the lab website. So I had secured the space kind of at the end of the school year last time, and it kind of languished for a while at the early summer. But I finally polished it off a few weeks ago and posted that up. It's nearearthimaginglab.org. I won't pull it now. Have you guys all seen the lab webpage at this point? We're going to build on that. I guess I get through the points here. I'm intending it as kind of a public face of the lab. It's not going to be a huge information repository, but I wanted to be able to let people know what we're doing, who's in the lab. At some point, I'll add some, like a list of kind of projects that we're doing so people can kind of get into that. There's some big overview kinds of stuff so people know broadly what we're doing, but I think it would be interesting to have a couple of particulars about the projects we have going on. And I'd kind of like to start and add like a blog to it so that as we're doing things, we can kind of post to that. And the reason I want to do that is we're generating and discovering a lot of knowledge that often gets disseminated via these lab meetings, which is awesome. We've got the lab wiki, which stores some of that information, but it'd be great to try to get that information out. You know, we kind of discover something. I mean, how many times have you gone to look for information and come across somebody's blog, and that's helped you out to solve a problem? And we could be a resource like that. So hopefully we can start doing that soon. I also want to use this for data archiving. So as people sort of generate, you know, if we do a scan of area X, we want to be able to publish that information out so that, you know, in 10 years, somebody wants a photogrammetric scan of White Top Mountain, Riley's data is up there and they can download it. So as we're generating data sets, let's archive them and put them up so that they're of use. There are some other places like Open Topography that we're using to archive some of that stuff, and it doesn't have to just be archived here, but the more the merrier. And so if you guys have any suggestions about the site, let me know. I've noticed a couple of things like this read more needs to be spaced out a little bit here. There are a couple of things I need to go back in and tinker with here. But if you guys have things that you want, Johanna and Charlie, you're not on the website yet, but you're welcome to be on there. You know, you guys have other advisors, and so I have to be a little bit careful about, you know, not looking like I'm trying to poach people's graduate students, because that's not what I'm trying to do. We're trying to be a resource here. But at the same time, if you guys want to, and whether we put it up there as, I don't know, like an affiliate status, or I don't know how we want to quite run that to make sure that everybody's cool with it. But
yeah,
you're welcome. I would love to have you on the website in some way.
Yeah, I'd love to.
Affiliate sounds good.
Okay.
Yeah.
Cool. Molly and Riley, I think, Molly, did you find a picture that I poached a picture of you from somewhere. I don't remember where, some news article or something.
That's fine from now. I don't really take pictures of myself or have any pictures.
Okay.
I have a lot of pictures of my cat, but no.
The one you grabbed of me is fine too, until I get a better professional profile pic. Okay, all right, sounds good. And I can actually put 2 pictures up there, which is kind of a neat thing about the way that this particular app for WordPress works. So there's like, mine has like kind of a photo of me doing a LiDAR scan, and then if you mouse over, it's got more of a sort of a headshot picture. So we can actually do 2. And those can link out. So if you've got a web page that you want to link out to, your own, whether it's a LinkedIn page or a more fleshed out web page, happy to do that. So just let me know. And I put as many sort of other links in there as I could. So I know, like Jim, you asked me to put in a link to your LinkedIn, so that's on there. If you've got stuff like that, let me know. That's actually one of the nice things about a website like this, and why I want to make sure people are listed, is that when you go out to get a job, and people are like, oh, I want to see what you're about, they can go to a web page, and if it looks good and if it's professional, that's going to help you, I think. So yeah, having that up there is a good thing.
Would it make sense to somehow incorporate GitHub or anything, like either link our GitHubs or have like a lab GitHub when we solve like simple problems or any data sets to upload it there?
Yeah, so the lab does have its own GitHub, which hopefully everybody is on. So that's where the lab wiki is hosted, but we can also host, that can be, we can have sub-projects in there. I guess that's technically a repository and connected to my account. I would encourage you all to get and use your own GitHub accounts, and as much as you're kind of creating code, definitely put it up there. I have a link to my GitHub account on the web page, so that's one of the little, I don't even think it has a good icon, but it's got a link anyway. But we should definitely add that stuff in there. It makes a big difference. People, that GitHub is one way that you can kind of demonstrate that you're pretty serious about coding. So people can look at your code. They can have, it will reflect better on you, I think, if we do that. So that's a good suggestion. Okay, so the lab move, obviously we're here, so you guys all found it, so that's good. As I said, shared space for geospatial research, not just ours. Let's see if we can get this down. Whoops.
Molly, it looks like your cat's on your shoulder.
The counter, she's not supposed to be though.
Okay, so and you know, you guys are getting the picture at this point that this lab is not just about my students. So whether there's plenty of people now that are a part of the lab that are other people's students. So I think half of us here are students of somebody else, which is great. Like I want this to be just a focal point in a community to exchange information. So you know, there's lots of people working on LiDAR. There's lots of people working on photogrammetry. You can talk to each other. And that's going to make a big difference in your research, just being able to bounce ideas off of people and ask questions. And it's gonna work out really nicely. And so I'm really happy that there are this many people, and I think we've got room to grow even a little bit more. So you know, be helpful. Try to, you know, I hope we're a focal point not just within our group, but to go out to other departments as well, or within the departments if somebody else is working on something. And you know, try to help them out. Like we want to help the department with kind of getting the nexus of our research out. So you're all kind of ambassadors for that. Oops, that's the wrong way. One of the things that I finally got done over the last couple of weeks was I finally got my NVIDIA grant application put out. NVIDIA has a grant, so they've got a number of great resources. I got attached. I was aware of this program when I took a deep learning course that they offered. There are some other deep learning courses that are being offered on campus. I don't have the link. I meant to put that in here, but I'll try to find that link. So for those of you who are interested in machine learning, you should take these things. They're super, it's like usually a half-day course or a whole-day course, and you can really learn a lot, well worth your time to do that stuff. So I had sat in on a course like that, and they had made us aware of these GPU grants, and NVIDIA wants to try to get these things out, being used in research. The grant application process is kind of opened and closed, and it was a little unpredictable. So I've been sort of like refreshing the screen every couple of hours, not really, every couple of weeks to see if like they had opened it back up again. At one point, it was like May, they'd opened it up again after it being closed for months. I was like, that's great. I'm going to do it this summer. And then like, you know, the weeks kind of rolled by, and when I finally sat down to do it, it was gone again. And so I swore that the next time it opened up, I was just going to drop everything I was doing and like just prepare the grant application. So I logged into this. I probably logged in on like August 12th. The closing for this new one was August 16th. And I'm like, that's fine. And I just like sat down and typed it up. So I put in an application for this. It was short. It was a little over 1,000 words. And it's an application for a GPU. So this is the Titan 5. It's a $3,000 graphics card for TBF. They've got all these things that are like, you have to like check a checkbox that says I have a computer that can run this, or I will buy one. And they're like, you're going to need a X watt power supply. So yeah, this thing's cool. So I'm looking forward to getting that in the lab. Lots of the stuff that we're doing is GPU centric. And the application itself that I put in was to adapt Waldo Tobler's pycnophylactic interpolation. So I had done some work on this last year, and I developed some Python code to do it. And so the grant is kind of to take that code and to turn it into GPU-enabled code. This is why this is important. Is spatial interpolation is a piece of a lot of puzzles. When you're working with LiDAR data, even when it's pretty dense, ideally you're going to generate something like a DEM off of that stuff. LiDAR data particularly, especially if you're only looking at the ground returns, is going to have holes in it. And you got to fill those holes in. And so the better the interpolator, the better the resulting surface is going to be. And Kriging, you guys know much about Kriging. So Kriging is kind of the gold standard. Some colleagues of mine had demonstrated the pycnophylactic interpolation. The way it works is actually produces a result that's numerically equivalent to Kriging. And the awesome thing about that is that the pycnophylactic interpolation should be, I don't know, 50 times faster. So if we can get this working, it can really make a big difference. The reason we don't typically use Kriging in LiDAR-related interpolation is because there's too many points, right? Millions of points, potentially billions of points, and Kriging just doesn't handle that many points well. Like kriging was originally designed to take, like weather station data and interpolate a good surface, right? When you're dealing with hundreds or maybe thousands, but when you get to the millions or billions, it just doesn't. It's like computationally inefficient to solve the problem that way. So this is pretty exciting, and hopefully we'll get the funding for that. The AR sandbox paper, this is one of the projects that Rob had helped me with kind of back in the day. So we built this augmented reality sandbox. One of my colleagues and I and a bunch of other people ran a study, multi-institution. I think there's like four institutions that were a part of this. We all did a little piece of it, collected data, we're publishing the results, and so it's nice to get that. We got suggested revisions back. If you're familiar with the process, you kind of submit the article to your journal, they send it out to review, they tell you that your paper sucks and that you need to do this other stuff. You do that stuff and then you give it back to them, and then hopefully it gets published. That's the point we're at. I did have to do a fair bit of rereading on some empirical studies. Basically think of it like psychological work on topographic map reading. I went through about 60 papers that have been published in the last 4 years on this topic. I think it would make a really interesting lit review paper. So if you guys, I'm still kind of thinking about this, but if there's some interest in participating and writing that lit review paper, let me know and we can coordinate. It's a bit of a gap in the literature. A lot of people have done a lot of work on this, but people haven't really put all of the pieces together. When most people are interested in kind of, I've got this new empirical research, and so they devote most of their paper to reporting that empirical research, and they do a lit review section that is maybe a page or 2 pages, right? And I think that this deserves more of a bigger treatment, in-depth stuff, systematic review. In our lab, we use the DJI Mavic 2 Pro for a lot of the work we do. I've been doing some comparisons between the Mavic 2 and some of our older stuff, which used a GoPro as the sensor. The Mavic 2's camera is about twice as good as the GoPro in terms of pixels. But the GoPro has an advantage in that it has a fisheye lens. So it's got a much larger field of view, which actually reduces the per pixel resolution. But the end result is that based on what I was doing, I think you can cover twice the area with a GoPro that you can cover with a Mavic, because the Mavic's field of view is so small, meaning you've got to take a lot of short paths versus like much bigger paths, right? So the bigger field of view on the GoPro is a real asset. This is the lab drone that I designed. So we called this the Busy Bee. The Busy Bee fell into a lake at NIU and died about a week before I left, so I didn't have a chance to rebuild it. Is that still laying around at NIU?
I have no idea, probably.
So I bought all the pieces for this when I got here, and I just haven't had time to put it together. So I took the opportunity to redesign some stuff. I redesigned this power distribution module. So now I was kind of trying to avoid soldering. Not that soldering is fine, but like I want to make it field repairable was kind of one of the catches. And so if there's soldering components, then now you've got to have a soldering iron. But I think that this is going to simplify things, so we'll just commit to the soldering. It's not very much soldering. This is the power distribution module. This is where the well, there's a little piece that goes before this, but this is essentially where the battery plugs in. And then these things are called ESCs, which are speed controllers. So they're what control how fast the motors spin. And then there's a flight controller that talks to the ESCs to tell them how fast to tell the motors to spin. So they're kind of like power relays, basically. One of these power relays is bad, so I need to replace it, or it needs calibration. I've also got a problem with the landing gear and the motor mount design. So I've got landing gear and motor mounts for these. They're all 3D printed. So the deal with this is that it's 3D printed, right? Except for the aluminum arms, we can manufacture all the parts that we need to do this. The reason I want to do that is so that we can take it out, and if we crash it, it's not a big deal. We just fix it, and it costs nothing. So that's kind of why we're doing this. Plus, it's fun. So if you guys have an interest in building drones, learning how that process works, 3D printing design, let me know, and you can get on board this project. So I need to have I need to redesign these in the landing gear. So if you feel like making up new landing gear and figuring out how to do that, I'll show you how to get started, and it's pretty fun to make that happen. The big thing is the REU project. So this is the stuff that I went down to Mexico for last year. It's been sort of a thorn in my side. I mean, I enjoy this stuff, but I need to get this paper out, and it's been sort of like 1,000 other things, and I just need to kind of sit down and keep my eye on the ball and get this out there. So one of the fun things about the lab is that we do a lot of stuff, and a lot of that stuff is fun. It's easy to get distracted. We're making landing gear through a drone when you should be writing your paper. So I have these problems as much as anybody. I need to do this. The journal that I was going to send it to is Cogent Geoscience. One of the editors on the one of the session runners at AAG when I presented my results in April was an editor at Cogent Geoscience. I thought, oh, this is maybe a good fit. But that journal has stopped taking submissions, and I don't know why. But Papers in Applied Geography actually had a call for papers related to applied drone research. So we'll probably target that one instead. So it's probably just as well. I've got 5,700 words kind of written up. Some of that is going to need to get, will go into the paper. So I'm definitely not at ground zero here. It's just sort of sitting down and making that happen. And the final work that I'm doing right now is the assessment of the tilt. So the gist of this part of the project, what it's really doing is we're trying to measure water levels in groundwater levels in the Yucatan. So we flew drones. We flew drones over cenotes, which are these exposed kind of surface water spots. So we're going to measure the height of those, but we need to do it very precisely because the difference in the Yucatan is so minor that we're talking about meters, and the error profile of GPS is meters. So we need to be we're trying to really, really wring out how much precision can we get out of these things, because it really is going to. What we tried to do is try to use as few ground control points as possible. So in the Yucatan, a lot of forest cover. How can we do this in a place? So traditionally what you do is you put a map down that has a big X on it, and you know where that is, or you figure out where that is with a GPS, and then you put 6 of those down, or however many you are in your area, and that's what constrains the problem. So your drone has a GPS, but it's not accurate enough to really do this right. So you have these ground control points. Now people are trying to use more precise GPS, like RTK GPS, to try to do that without ground control points. This is essentially trying to use one ground control point to recenter the cloud, and that will work as long as there's not a lot of tilt in your image. So the question then becomes, how much tilt is in the image? So one theory would be, well, I'm flying over this large area, my GPS has individual error, but all of that's going to get kind of averaged out, right? So like, even though your GPS is only accurate to within a couple of meters, you're averaging it over all these observations. So maybe you get a bonus there, right? Sort of like leaving your GPS on the ground for 15 minutes versus 2 seconds, right? You should get a better fix the longer you fly. And maybe over a larger area, the tilt goes away, but maybe not. So I ran a simulation, and I had reported on this at AAG. I ran a simulation, and that indicated that how you fly, so the flight path can make a difference in how much tilt. How big the area is, so the bigger, the less tilt. Long, skinny routes are more likely to have tilt than kind of square-ish or circular routes. But we hadn't done any empirical work to verify that. So we took that was all sort of, we used a real GPS track, but we kind of ran a Monte Carlo simulation to figure that out. What I wanted to do was do this for real, right? So I flew a drone 20 times along this route, essentially generating 3 different flight paths. So one was what I call a sawtooth, where you fly these kind of short legs like that. One was longitudinal, where you kind of fly down the long edge and back, right? And then a double grid, which is the composite of those two. And so we would expect that the double grid should be more accurate, right? Because you're getting more points, you're flying longer, it should constrain the problem. So that part was not, we were pretty sure that that was going to work. But the question is, you know, what is the actual rate of tilt for this stuff? And is it better for one kind of flight path versus the other? So I flew 20 of these. So we got 3 different flight paths, 20 flights. I placed RTK GPS unit at these 3 points, which these are some concrete pads that were on the property, so they had a good open area. I placed these for 24 hours, so we got a really, really good precise fix for where those were. And then I used the iterative closest point algorithm in Cloud Compare to try to snap those together, right? So I've got 3 points in space, I've got a point cloud, I run ICP, and it snaps them to the nearest best location. That's a way to kind of figure out what the error is. The way I did this was Cloud Compare. We usually use that as a GUI, right, to load and look at LiDAR data, but you can run Cloud Compare via the command line. And you can do basically anything that you want to run that you would do in Cloud Compare, you can do from the command line, which is awesome. And so I used ICP using the command line and then used Python to automate it. So Python would call Cloud Compare, it would do the ICP, it would write out the results, and then I'd read those results back in and store them essentially in a little database to try to figure this out. And a little bit here, so Cloud Compare would write out a transformation matrix, and I'll show you what that looks like in a second. And then I would compute the angular tilt from that transformation matrix. So the idea is that a transformation matrix, well, I'll get into that in a second. But what I wanted to do is figure out, is it tilted this way, is it tilted that way? But I didn't care whether it was this way. So I had to exclude, I only wanted to know the roll and the pitch, but not the yaw. So I wanted to exclude that from the calculation. This is kind of what that process looks like. This is kind of just for documentation. When we're presenting these things, it's good to just talk about what the results are, what we did. But ideally, it's good to sort of get some real nuts and bolts here, so that if somebody wants to do this later, they can see, how exactly did you run Cloud Compare from the command line again? So that's the command, and I can, I'll publish the whole Python code along with the archive here. So you can see I'm invoking Cloud Compare. I'm doing some things like making sure it doesn't save some stuff. I don't care about timestamps. I'm adding a global shift. I'm reading in the RTK points. I'm reading in the point cloud, and then dash ICP is run the ICP. And what that does is it opens a little window of Cloud Compare. It runs this, and then it spits out this registration matrix, which is a 4x4 array of numbers to describe how, using linear algebra, you can transform the coordinates from one reference frame to another. So this is a common way in which we do like reprojections. So if you're reprojecting your data in ArcGIS, that's what it's doing in the background. It's figuring out how you take one coordinate system and change it to another one. And whether you're going from latitude and longitude to UTM, or you're going from these 3 points to this point cloud, it's all the same. It's just a multiplication using linear algebra. And it spits out a matrix that looks like that. And then basically we're using this code. Somebody was nice enough on some blog to post a little function that reads in a transformation matrix. Oh, I put the wrong one in here. This is the other one, but this is taking Euler angles, the roll, pitch, and yaw, and making it go to a transformation matrix. I used the other one, which is transformation matrix to Euler angles, and actually I kind of went back and forth. So, have you guys read anything about transformation matrices? Have you run across that in any of your stuff?
I think I did some in my vector calc class.
Okay, cool.
That was it, just like problem sets and stuff.
Yeah, like no application, right? So this is one of those things where if you're using Python, you're using NumPy, this is how this stuff gets done. So this is worthwhile for everybody to just read a blog post to just get a little bit of, at some point many of you will run into this problem, and just kind of knowing enough to know where to look again is fine. So to just do a little bit of looking. It's extremely powerful, and with something like NumPy, the syntax to do this, while a little bit arcane, is really fast. It's like A times B gets you your reprojection, and all using linear algebra. I don't even know in linear algebra that well. I just know it enough to get the job done. Love to take a class. These are the results. So again, the goal is how much tilt shows up if you're flying a flight and it reconstructs it. Is it this way? Is it that way? Is it flat? So, and these are real flights. So 20 real flights, 3 different kinds of missions, and then I ran the ICP 50 times. So an ICP is not deterministic. It's a little bit random. So you can run ICP once and get a number, and you can run it again and get a different number. So don't just take the first one necessarily. I mean, it's probably ballpark close, but like I was finding enough difference that I was like, I don't want to run this once. I want to run it 50 times. And so we ran 3,000 individual ICPs. And so Python makes that possible to sort of just automate this, a couple of loops, spit out the results, and let it run for a couple of hours, and you're done. So how did this turn out? In the simulated study that we did, we found error rates that were between, call it 0.2 and 0.5 degrees. So not very much. How much tilt is in there? Half of a degree, maybe. So not very much. When we ran the empirical stuff, that was higher. So that we're talking about 0.6 to a little over 1, call it 0.8 of a degree, a little bit more. That makes sense because in the simulation, there's only one source of GPS error, but when you're flying, there's actually at least 2. So the way that your image gets timestamped is it uses a time comparison of where the drone thought it was from its flight log to what the camera's timestamp says. And if those are off by half a second, a quarter second, then not only do you have GPS error, but now you have locational error from that geotagging process, right? If you're flying at 6.5 meters per second and you're off by half a second, now you're off by 3 meters, right? Does that make sense? So there's extra error coming in at that point. So it's not too surprising that this is higher. What is really interesting to me is that in both cases, the double grid was kind of on the low end. The simulation suggested that flying a sawtooth, so this is the simulation result, simulation suggested that flying a sawtooth was practically as good as a double grid. So if you're flying, so the reason this matters is that we were flying along a road, and we flew down the road and back, right? Down, 500 meters, and then back on the other side. And the simulation suggested that that was wrong, that we shouldn't have done that we should have done this. And that would have led to a better reconstruction. Lots of people don't think about how flight paths are going to impact the reconstruction, but this is showing that it can matter. Maybe not a ton, but maybe a little. So what's interesting is that this empirical piece is suggesting the opposite, that longitudinal actually has a lower error rate than the sawtooth. So simulation, empirical results, we've got a really big discrepancy here, and I don't know how to explain that yet. I have not figured out why. I reran this, not just reran the code, but took it all apart, stripped it down, built it again, got the same result, took it all apart, built it down, stripped it again, trying to figure out why this discrepancy happened, right? Is it something that I did in the code, or is that real? At this point, I think that's real, but I don't know why that should be the case. So, you guys have any ideas? We'll think about it. Let me know. It's a bit of a mystery, and you always kind of dread that point in writing up the paper where you're like, and then this happened, and then you kind of just don't say why, and then a reviewer is like, okay, well, why? And now I've got to say why. So I don't know why. I just happened to be on another paper. It kind of stalled me out for a while. I should have an explanation for this if I'm gonna.
Did you have it like stop at each corner, or was it a roundabout, or what did you do?
How did I fly it? Yeah, so you can. It did not pause. Yeah, I don't know why that would affect the flight path though, unless it's okay. So maybe it's
because it's based it off of the camera,
tilt
right?
More, yeah.
It's just gonna have to bank a little bit more to make that turn without stopping, but and then if you stop it entirely though, it's gonna roll back, pitch backwards. So that might be an issue as well.
So the only difference that I can think of off the top of my head is that would make. So definitely, I get more sky whenever it turns, right? Because ordinarily, like on a DJI, we've got a gimbal that keeps the camera oriented in the same spot. But to save weight, I took the gimbal off because the gimbal weighs, 300 grams, and so you can get longer flight times. And when we were in Mexico, I took the gimbal off for that reason. You get some sky in the image then whenever it banks, right? Because now my camera comes up and it catches the sky. I don't know whether Pix4D has changed something, but it was doing a much better job. At first, I was carefully removing anything that had sky in it. It still slows down.
Yeah.
So you still have this moment where it hits the right spot before it starts to bank. So you can actually just remove those pictures from the reconstruction. But the reconstructions were actually so good that I didn't bother anymore. I took the time to take them out, and then at some point it was an accident or something, and I just like left them in there, and I was like, oh, that turned out fine. And then I took a couple of hours to like actually compare the two. It doesn't seem like that's a problem, but it would be interesting. So if we ran one where we just took out the ones where there's any banking, then it shouldn't matter. The way the trigger works on this is that it takes an image every half second. So it's only the camera that's doing triggering. And then instead of like, if you use, well, Pix4D capture on the DJI drone will actually do this too. It's time-based, weirdly enough. Like you think it's location-based, you're telling it to like take a picture at these like overlaps, but it actually just does the math and figures out what the camera delay time has to be to make that happen. So that's time-based as well, to my surprise. It's good though, because then if you lose connections, it still works, right? So if you get stuff's not talking to each other right, you don't miss a photograph, it's still doing its thing. Anyway, that's a good idea, and I'll look into that. Okay, so I'm only here until September 6th. Many of you know that I'm going to be off on parental leave for much of this semester. I'm going to be here on campus until September 6th, so that'll be our last lab meeting, and then probably that afternoon I'll be hitting the road. So in the meantime, I got a lot to do. I got to fly some tornado scars, and Sam may help me out with that. I would like to finish Busy Bee and at least get a test flying, so I don't forget where I am with that. I want to train all you guys on the lab equipment that you're interested in, so especially the 3D printer, which you guys should play around with. It's lots of fun. You've got plenty of filament. It's a good time.
Do we have different kinds of filament?
We have some different kinds of filament. We can get more if you're interested. I got some glow-in-the-dark stuff if you're...
Does it do like metal?
What?
It doesn't like do more harder like metal material?
So I haven't tried it. And part of the reason for that is I've heard some of those kinds of materials can clog the nozzle over time. So
yeah,
short answer to that is no. But there are some really interesting filaments. We've got, I've got a little bit of, mostly we use PLA because it's cheap and it's easy to use. I've got some copolyester, which is a little bit stiffer and stronger. And then I think I may have a spool of ABS as well. So we've got a couple of different kinds of materials. PLA works pretty well. But anyway, if you guys are interested in that, it's fun. There's also the library has 3D printers as well. And then I want to get everybody access to the lab computers. We'll talk about that as the orientation. But there's going to be different computers in here. We've only got one in here now. The one that's in my office is going to come in here, and we'll buy one more this semester. Those won't be assigned to individuals. Those are going to be sort of lab resources. But that should be enough that if somebody wants to run Pix4D, there's two more. You're doing virtual reality stuff. Like there's enough to kind of go around. And if you kind of gravitate and like, this is the one you usually use, that's fine. But anyway, I need to get you guys logins for those as well. Okay, that's it for me. Sorry, I always go a little bit long, so I apologize about that.
I have a question. I know you mentioned earlier over the summer that you like the new students to give you lab pitch or like thesis topic pitches. When would you like that since you're going to be gone?
So we'll talk about that in orientation a little bit in a couple of weeks.
Okay.
Yeah, and hopefully you've all started to sort of jot down a couple of ideas. You may not be up to 5 yet, but maybe you're up to 2 or 3.
So what orientation are you talking about?
So after the lab meeting, I'm going to do sort of a lab orientation, kind of getting everybody in here used to. You guys probably have had enough orientations, but I want to give you guys a little bit more depth about some of the stuff we do in the resources. Everybody's welcome to stick around for that. There's no private information in there. Some of that stuff you already know. Some of it's sort of like, but maybe some of it's new. So that'll probably take about 40 minutes or so. So hang around after the meeting. Okay, all right, I'll wrap things up. And for the new people, again, I always go long. The target for these should really be more like 10 or 15 minutes, so sorry about that. Can't help myself when I get into the details. Not everybody's needs to be this long. Mine should not be this long either. And I want to move this. All right, Hudson, you want to go next?
Sure.
Did you post it on
It's on Slack.
Slack?
Yeah. I think it's in one of the comments.
Can you guys remotely see this? Molly and Riley?
Yep.
All right, cool. All right, I'll move
All
over.
right. Let's switch with you, or?
Yeah, go ahead and switch with me.
Okay. So my name's Hudson. I'm a second year student. That's what you guys know. Some of the new people, maybe not. But yeah, so if I just press here, or?
Oh, you can use this too if you want.
Okay, this works. So yeah, a lot of my work is considering geovisualization techniques in virtual reality for point clouds and how point clouds can be manipulated, reclassified, segmented for use in VR applications. So a user can go in and see that, all right, like this classification is wrong, and then they can go and manipulate it and then export it in such a way to correct it. But yeah, a lot of that work in regards to segmentation and classification is a whole nother spectrum, and but they only work so well in a lot of senses. You've worked on a lot of classification techniques in regards to ground points, LiDAR points, and a lot of times users don't have ways to interact with that. On a 2D surface, you can't really make much of 3D objects. But the hope is that doing so will allow for a more dynamic workflow for people to go and interact with the point cloud over a web experience. So web VR is something that's more readily available. You might have seen, like, I don't know, the little goggles at the bottom of a certain simulation where a user, if they have a headset, can immerse themselves into a scene. So the goal there is to allow for a user to do that with their own point cloud that they can then reclassify to fit their needs. So doing so, I've been working with a library called Potri, which utilizes a backend web server in order to display the points to the user, but also being able to try to bring that into a game engine such as Unity, which is kind of the rendering going on there. But so it was exciting to hear about the GPU that we got, because millions of points is kind of hard on the processing. But right now I've been kind of working on prefabs in regards to ways that the user can interact with it. So similar to like how, I don't know if you were to play a video game in VR, like you have to be able to select certain points in the point cloud to be able to segment it out and then change it from its original attribute to a new one. So that's kind of what I've been working on. And then kind of like in parallel with that, I've been looking at some deep learning libraries in regards to TensorFlow and PyTorch. So these are deep learning libraries designed for machine learning for neural networks, and they're all Python based. But TensorFlow is more applicable, I guess, in this sense for a large data set such as point cloud. And it's super high performance, and it's used a lot of times for, there was like some learning challenge for building footprints that some company put out. I think it was
Microsoft one?
Yeah, Microsoft, where they were implementing object detection and machine learning in order to extract building footprints over large areas of the United States. So I thought that was an interesting kind of parallel thing that might be useful down the road in regards to machine learning.
So one of the things I want to pipe in here, and when we're doing these lab meetings, don't feel like a lot of what we're talking about here is just intended to get the conversation rolling. So don't feel like you can't stop somebody and ask a question. I'll do that often, but you guys should probably do it. There is have you guys heard of the AI for Earth program from Microsoft? So it's a new kind of grant opportunity, kind of mini grants, but essentially what they're doing is granting time on the Microsoft side, like the Azure servers or that platform, to do basically machine learning tasks, and all of it's oriented towards sort of environmental-ish causes. I would love to try to put in an application for that. So if you guys have some time, check out the AI for Earth program, and maybe we can see what we can cobble together. They're working closely with Esri, and a lot of the stuff is sort of really, so TensorFlow and PyTorch are kind of on their list of things. It'd be neat. So we can kind of come up with a thing to do, even if it's just sort of learning how this stuff works, right? So I've never put anything up on like the Microsoft Azure system. It'd be fun. So,
yeah, I was really excited about it, reading just about the capabilities of TensorFlow and running through some of the tutorials. I don't know, maybe do something with like the Amazon on fire, right? Like everybody's freaking out about, which is true.
we do also, by the way, have 2 1080 graphics cards, so we do have a couple of good GPUs in the lab already.
Cool. And then also kind of like a parallel project that Dr. Pingle and I were kind of researching and figuring out. I was kind of tasked with looking at. So this is a web-based 3D labeling tool for point clouds. It's called Supervised.ly, or Supervisedly. I don't know. I didn't get an accurate thing of it. But so it's basically that you sign up on a web page similar to kind of what we're looking at doing, and then you're able to import your own point cloud, and then be able to annotate it in whatever ways. So as you can see, what they're doing here is segmenting this car, and you can see in the the picture associated with that scan that they are able to overlay it with one another to kind of give it extended use and flexibility. But the point cloud labeling tool offers like different ways of selection. Here they're doing like the cuboid, being able to view it from different sections, being able to manipulate it and then annotate it in such a way that they can recall it later. But this is a direct application of what's called KITTI data, XML tracklets, which are the data associated with autonomous vehicles using LiDAR in their LiDAR packages for real-time dynamic LiDAR. But yeah, so I thought this was a really cool parallel project in that sense, but they also take the point cloud format. So the KITTI data website was actually down when I tried to use it, but it seems to be back up now. So it would definitely be something worth looking into and doing more. But yeah, you can import additional images, being able to overlay like the actual image onto the point cloud is incredibly cool, that you can really segment it based off of that and have kind of like a fail-safe to look at. But yeah, they get the ideas of camera position and the orientation of space from each one, and then some kind of future implementations that they've kind of talked about was object tracking, semantic segmentation, some new types of selections, so polylines, being able to track like grids of wires, and support for other import formats such as other point cloud formats in that instance, whether that's LAS or anything else, as well as the integration with the system. So the Supervisely is not only just this; it's a like machine learning neural network library that they use for multiple things besides LiDAR. But yeah, I joined their Slack channel and was kind of posing questions in regards to implementing WebVR. There's other libraries or other packages that can take web pages, and if you have the right data and the right back-end code for it, you could turn it into a VR scene. So I was kind of just poking around, seeing if people had done stuff like that with this implementation. So, but yeah, I thought this was pretty exciting in regards to that and the machine learning. And yeah, so that was pretty much it. I don't know how this slide got in here, but this was a whole slide. But yeah, I've kind of just utilizing the HTC Vive and results to that. And there's, I don't know if these will play, but these were some of the point clouds that we got. Unable to play video. Okay. Oh, this one wants to play. But yeah, so these are just like first person view of that. So it's a little finicky at first, but hopefully kind of trying to refine it and bring it to a more stable place to segment it and do all the stuff that we want to do with it.
That's in Unreal.
Yeah, this is Unreal.
Cool. Did you bring the Vive in today?
I literally had it out on my table and I walked out of my house without it.
I was afraid I was going to do that with my keys to this lab.
Yeah.
And because they're on a separate key chain.
Yeah.
Sure, I'm going to forget that.
Yeah, it was annoying, but
That's all right. So we've got the Vive and the Oculus both. So we'll set up one of those this afternoon, or set up the Oculus this afternoon.
Is the Oculus the Intel?
Facebook owns it now.
Okay.
Yeah.
have you seen the new one that they have? It's like a smaller, more manageable one, I guess what they call it.
Oh, is it?
Yeah.
I've seen some traffic on Facebook, but I was like,
Yeah.
well, I'm not going to buy anything else now.
It's supposed to be like their cheaper base one, but it's supposed to perform just as well.
Yeah, cool. Cool. How cheap is cheap?
I think relative to what it was, $300 or something like that.
Oh, okay. A
Yeah,
little cheaper.
yeah.
It's pretty fun. We'll get it set up, and if you guys haven't seen like an immersive Google Earth, it's pretty awesome. Okay, so no presentations over here. We'll come back and do updates here in a second, but Riley and Molly, you're still with us?
Yep.
Molly, you want to go next? Can you hit the
Sure.
stop?
Well, Hudson, quick question.
Yeah.
For the deep learning Python libraries, are a lot of them just functions that you call on objects you create and you don't actually need to know too much about, like how to create the deep learning algorithms themselves?
So a lot of it is based off of like you have to train the algorithm in order to do what you want it to do. So like some of the tutorials are like it's like a object recognition of like determining whether a picture is a shoe or a shirt. But in order to do that, like you have to train the algorithm to say, all right, this is a shirt if it looks like this, or pixel-wise looks like this. So I mean.
But they have the algorithms created, right? You don't have to.
Right.
Yeah.
Okay, that's cool.
It's easier to get started than you might think. There's some good tutorials, and like a lot of the back end stuff is done, and it's gotten better than it was even 2 years ago.
Yeah.
So.
Neat. Should I share my screen then?
Yeah, great.
Or stay here.
Might as well.
Okay.
Can you see?
Yep.
Sweet. Okay, so I'm going to kind of just go over a brief overview of everything that I've kind of done this summer so far. If anyone has any questions or wants me to dive a little deeper into any of the topics, just let me know as I go on. So the first thing I've been working on is working on the NIH grant that's looking at the impact of surface mines on birth defects in Central Appalachia. And we're still at the point where we're still trying to clean the data. Central Appalachia, we're defining as 4 states. And we have all birth records for those 4 states between 1990 and 2015. So the first step to cleaning the data was geocoding it so we could come up with individual exposure metrics to these surface mines. So it's just been a lot of data to sort through. So coming up, and I'm almost done with this, we're creating 2 different data sets. We're creating a clean data set of birth records at the individual level. So this is down to the house. And we're also creating another data set at the postal level so we can do 2 kind of analysis at the individual level and the postal level. Part of the problem with Central Appalachia is a lot of the people there use PO boxes. So we don't actually want to remove, like, I think is almost like 40 or 50% in some states of our sample size. So we still want to keep that there. But the reason this grant is unique is because we're actually geocoding to individual records. So the picture here on the right is actually, I think, the common geography problem when working with vector data. The green is highlighted in blue, and that represents postal boundaries or ZCTA boundaries, and then the red represents the county boundary. And as you can see, they're not at the same spatial resolution. I can't get them to the same spatial resolution because it looks like the postal boundaries are a higher resolution, and that's the highest county boundary resolution on the census's website that I could get. So in order to define which, we basically have a list of what counties are defined as Central Appalachia from the Appalachian Regional Commission. And to create the postal level data set, I need to go in and determine which zip codes count as Central Appalachia. So we're currently in the process of deciding like what threshold do we want to kind of cut off zip codes due to this spatial resolution issue. So if anyone has any advice or has an idea, I think we're going to say like, we're gonna intersect it and say this amount of area of counties in this postal boundary. So if it's greater than 2%, then we're going to say that's in Central Appalachia. But if there's any other ways to do this.
I'll think about it.
Yeah, it's really annoying. But the other issue with this project is the sample size is already really small. So we don't want to, like, I guess, remove more than we should. So I think right now that's what I'm doing, is saying anything over 2% is considered Central Appalachia. So another portion of the project is, since surface mines emit a lot of air pollution, we thought an exposure metric would be to kind of determine an airshed around these surface mines. So what I've been doing is looking at 3 years worth of air data, and this shows kind of air trajectories off of a certain point. And I figured out how to use the FTP request to download the data because it was 365 times 3 and I didn't want to click that many times for 3 years worth of data. So if anyone ever ends up using NOAA's meteorology files and you have a lot to download, let me know because I figured out how to download them automatically.
Cool.
Another good way to do that. Have you guys used wget to download stuff before? So if there's an FTP site, that's definitely the way to do it. A lot of times people will post links not as FTP links, they're just like HTTP links. And if that's the case, you can use a little program called wget that's like, there's a Windows version of it, but it's bad. But you can open a Windows subsystem for Linux and do it that way. So if you get to that point where you got to download a bunch of files from a website and you don't want to click 300 times, there's actually there's a little note on it in the lab wiki. I think I made something for wget. So.
Yeah, I definitely didn't want to click that many times, and I probably would have missed some anyway or duplicated it.
Yeah. It's always, as a lab philosophy, there's some repetition is fine, right? Like sometimes it is faster just to click on something 20 times than to write code to do it. But there's a point at which it's not. And push yourself to figure out how to automate things. The more you start to try to not click on things, the better you'll get at it and the easier it'll be the next time.
So the reason we were looking at 3 years of data is because we wanted to get an idea of what the air patterns were doing to start to define the air sheds and how we should create buffers off of the surface mine polygons and which birth records to include, like, oh, they are 75% affected by the winds that are passing off the surface mine. So this is kind of, we picked 2 different sites. Site number 1 is a higher elevation and is about 80 miles, I think, away from site number 2, which is at a lower elevation. As you can see, one's like around 3,600 feet and the other one's around 500. And then we concatenated the files by season. So this is winter, this is spring, this is summer, and that's fall. So we realized that they really weren't changing that much. So I'm hoping, I'm waiting for Dr. Marr to get back to me, but I'm hoping that means we can, instead of running this for every single surface mine point and creating a new buffer for it, we can just have a general buffer off of these surface mines, because I think this takes like 15 minutes to run each point. So I don't want to create it for like 10 points for each year between 1990 and 2015.
So this is air quality data, Molly?
It's air trajectory data. So those rings represent the frequencies in which the air passes through. So the smallest ring, I believe I have it set to, if a point starts in the blue dot, then 90 out of 100, I guess, airflow points will go through that area. The next one's 75, so 75 will go through that. And then I think the other one's 50. From like starting there, 50% of the air trajectories will go through there.
So it wouldn't be like photosynthesis related from winter to summer, that there couldn't be a relationship there between that change, could there?
I don't think so. I think it's just mostly wind patterns. I know that the data is created from a model and it's not actually like real data. I think they have real data points and then they derive for different locations from this model.
So
Okay.
are you guys running, so you guys are running the processing to figure out what these polygons are, right?
What do you mean?
Like, did you write the, how are these polygons created? Are you creating?
They're created using HighSplit.
Oh, HighSplit, that's right. Okay, I remember that.
NOAA's, I don't really know what it does, but.
Why are they so pointy?
It's the resolution that the data's at. It's 12 kilometer resolution. I think that's the finest resolution data set. We were using one, I think that was like higher than that, and it was a lot smoother, but she wanted it to be, I guess, at a smaller resolution, so. I don't really know too much. She kind of just tells me what to do and then I do it, and then she looks at it and she's like, do this, so. But yeah, once we define the air sheds and I can start buffering out the surface mines, then I can start creating a data set of the individual birth records saying this was pre-mining, post-mining, and during mining for each of the years that we have the data for. And that will be a Python script that I'll write at some point, I think. So for the LiDAR project I've been working on, I didn't do anything this summer. But this is just kind of a to-do list for myself. There was a bug in the Python scripts that I had written, and hopefully it's fixed by now because it's 5 months since I submitted the request to fix the bug. But if not, I'm going to have to redo it using Model Builder, and I've been trying to push that off because I don't really know how to use Model Builder and I don't want to. And then we're also looking at extracting like roof forms from LiDAR points to make the model more realistic. And there are a few resources online that already has that up. So we were going to walk through them and see how it looks in our final model that we're creating. So this summer I interned at the MITRE Corporation. They have a site in Massachusetts and one in McLean, Virginia. And I interned in the one in Virginia. I don't really know how much I'm allowed to say about the project I worked on, but this is what they approved from my LinkedIn. I was basically working on change detection for their planning and development for marine environments project. And this project was really looking for how do you update port information for the government. So I think one of the big problems with ports is that every 10 years they write a report, and by the time they get it, it's so outdated that like it's kind of pointless to look at. So they're hoping by creating an automated change detection algorithm where it'll just scrape the internet for the data, input it and spit it out, that can help the government determine what they need to allocate certain resources at different ports. And the cool thing about this is I actually got a verbal offer, so I'm probably gonna accept it. They said they would send me the actual application just because they need me in the system, and then get an offer package together for me this semester, and then I'll start my clearance process.
So is this would you take that after you graduate, or is it a more immediate?
I said I would like to do it after, and they said that the start date's extremely flexible. So
great.
Yeah, I mean, if anyone's interested in more like government work, let me know. I think MITRE is a not-for-profit organization, and it manages 7 FFRDCs. And they do have a geospatial and analytic department, and that's the department that I'll hopefully get a job in. So,
Sam, you're thinking about government stuff, right?
Yeah.
You should talk to Molly at some point about that, shared experiences.
Sounds pretty interesting. I definitely will.
yeah, it's a fun organization. I thought the work was really interesting, and I really liked the people in the department. So,
Do they do a lot of coastal marine type stuff?
not that I heard of. So I was primarily working on this project, but I mean, I don't know how much ports would count as coastal marine. We weren't really looking at it from an environmental perspective, just more of a change detection and what, I guess, like dock extensions, any houses built or buildings built.
Right.
But I do know they were looking more from an environmental perspective in terms of disaster response, but not necessarily, I guess, marine life or things like that. So, and a few other things that I've been looking into is Jupyter Lab.
Oh, how do you like it?
So I haven't really, I know it's supposed to be really interactive, but the GIS library portion isn't interactive. So what I thought the Esri's update, when they said they were releasing Jupyter Lab, it was going to include ArcPy, but I think it only includes the ArcGIS API, which to me is like the same capabilities as it was in Jupyter Notebook.
Yeah.
So it was not as impressive as I thought it would be, but I do like the user interface more. But in terms of capabilities, it's basically the same as Jupyter Notebook to me right now.
Yeah.
But it looks good.
Anybody else use Jupyter Lab? Yeah? How do you like it?
I'm not too big of a fan of Jupyter in general, but Jupyter Lab's a good. I like that you can like, it's in the browser window, so no matter like how like, crappy your computer is, you can like connect it to like a big server and have it running on there.
Yeah.
Yeah, because you can't really do that with Spider.
Right.
You can do the X11 stuff, but that's confusing.
Right.
Yeah.
Okay. Yeah, I tried it. I've tried it a couple of times and been like, I don't think this is for me. I should. So yeah, I usually kind of bounce back and forth between Spider and Jupyter Notebooks. This seems like it would be the perfect merging of the two, but every time I try to use it, I just get annoyed. So
they have dark mode too, so I feel like
There you go.
dark mode everything.
Really
cool.
Yeah, I hope they fix it so you can run ArcPy in it or other GIS packages that are more interactive. I feel like it wouldn't be that hard. They just have to somehow grab the map frame from ArcGIS Pro or ArcMap and just display it after you run it over a certain extent.
Yeah.
But, yeah, I think it's fine. It's same as Jupyter Notebook to me though for my purposes with it.
So when you installed it, where did you do the install from? Like, how did you put it into your workflow? Because I've done the install straight from like Anaconda. Did you do it differently?
Okay, so the first time I installed it was at MITRE because they were interested in looking into it. They had been using Zeppelin, which is also an interesting alternative. But MITRE had so many firewalls and proxy issues that it took like 15 steps for me to figure it out. And on the website, it says 3. So I think on my personal computer, it'll be fine with just the 3 steps that they posted. And I think it was through Conda, but through MITRE, it was such a pain.
Yeah, and Sam, when you did it, how did you get it? How did you do the install, or did you get it? So what I'm getting at here is there a good way that we can do this to get it to connect? Like, can we shoehorn the ArcPy stuff into it? Because I've done. I mean, you can do. Like, could you just do this from your ArcPy or from your not ArcPy, but can you do this from just like your ArcGIS installation?
I've only messed with it through Anaconda, which is like super easy to install. But the ArcPy, I don't know how those things connect too much. It's kind of confusing.
Maybe it's worth spending another couple of hours on sometime to see.
Well, I did like what you did in class. I created a new environment and then I copied over the ArcPy environment into that one. Then after I installed it, it was just opening the command prompt. It has to be in admin mode with Jupyter Lab, and it doesn't for Jupyter Notebook. But in admin mode, it was just like activate that new environment, and then I typed in Jupyter Lab.
Okay.
And it kept all my libraries and everything.
So which part of working with ArcPy didn't work?
Well, it doesn't display anything after each step.
Oh. Yeah.
It'll just be like outputted object X6012 3 or something.
Okay. Okay. I got you.
But I wish it were more interactive. Like if you ran a geoprocessing tool or selected something, like it would show that selection or.
Yeah, I've actually, that's one of the things that I've been after a couple people from Esri, and they always kind of hem and haw a little bit about some of this stuff. So I imagine they're working on it because everybody's got to be itching for this. But
Yeah.
like I'll see them demo something at a conference and be like, "Can I get that?"
Yeah, like,
They're
where
like,
is
"Yeah,
that?"
email me," and then I email them and it's not working out. So.
I mean, it seems to work with the ArcGIS API, but I don't know how it's any different than how it ran with Jupyter Notebook.
Yeah.
It's still displaying like the web map. It's still displaying if you like add a layer, if you do anything to that layer, but not with ArcPy itself. So that would be, if it did anything with ArcPy, then I would just be using it all the time.
Right. Right. Yeah. Well, let's make that kind of a short-term goal and see if we can figure out a way to make it happen.
Yeah. I've been using, there's a Python library called Rasterio.
Yeah, yeah, I love Rasterio.
Yeah, so I've been using that kind of as a workaround for raster-based things, but it doesn't do shape files or anything, or I guess vector data, so I don't really know.
Yeah, GeoPandas is your vector data.
Okay. So, but if it did automatically, that'd be awesome. And then the other thing that I've been using is ClickUp. It's a project task manager. So if anyone likes to-do lists, this is really awesome because you can invite people into your project if you're working on like a group project or something, and then you can assign tasks to them and it shows up in their email, and then you can say like open, in progress, closed, and then yeah, this has been very helpful for my research partner and I for the NIH project. And it's free as long as you don't upload anything onto it. It's free and you can create as many tasks as you want.
Does it seem like the kind of thing that would help manage like thesis projects then? Like, would this be a good way for me to like keep tabs on what you guys are up to, or does it seem like overkill for that? Better for collaborating with another human?
Yeah.
Okay.
I also have my like own to-do list, but it's been helpful for Lauren and I since our data is so intertwined with what we're doing. Under our thesis tab, if I need something for my part of it, then I'll like just tag her and then say like my stuff is dependent. Like you can set dependencies and everything. So I like it. It's pretty intuitive and I like that it's free. And I also like that you can add a bunch of people onto it. So even for lab stuff, if you wanted to create, like you could list a bunch of different wikis that you wanted and then just assign people to it.
Cool. I wonder if you can kind of load it into Slack like you can some other programs.
I don't know about that. I haven't looked into it.
Can you take a quick look, Molly, and see sometime?
Yeah.
Cool.
Well, that's all I have.
Awesome. Thanks.
Yeah. Thank you.
All right.
There's a Slack app directory for ClickUp.
Ah, very good. Yeah.
Cool.
I have to run to get my laptop inventoried for some reason. So, but I might come back for the lab orientation.
Okay.
So
Yeah, sounds good. All right, we'll see you soon.
see you.
All right, so I'm on two devices here. I'll try to share my screen. Let's see. Does that work?
Yep.
Cool. All right, so I'm going to be kind of brief here. Bird of prey here. This is one of the default layouts I found on PowerPoint, but August 23rd, little Near Earth Imaging Lab update after a sort of productive summer. I worked all summer with John Boyer editing his the 10th edition of the Plaid Avengers World. It's globalism versus populism, or globalization versus nationalism. So that's all sorts of interesting stuff, trying to update with current events and all that.
Yeah. You guys know John Boyer?
Yeah, there's Plus Monograph.
Tell everybody about the Plaid Avenger.
Okay, so we have a professor in our department, John Boyer, who's got his own cartoon character, and he's called the Plaid Avenger. And so he's developed this persona, you know, this world traveler type guy who goes around and, you know, pretty much knows everything about world happenings and events. And he's kind of unbiased, not too opinionated, and it's really interesting. The way he teaches, students seem to really engage with, and I've been working under him for the past year, and so now I'm kind of a head TA and trying to orchestrate things to make this class work. So it's really cool. If you haven't heard of him, check out plaidavenger.com. Pretty sweet.
He drives around like a Scion that's completely plaid, and he has his own jet, and everybody knows who he is on campus.
He's like
He's a celebrity.
he teaches the World Regional Geography class, which here has what 1,000 some students.
Like 3,000.
3,000?
Yeah,
A semester.
it's like all the freshmen take it, basically.
It varies. So I know Jim's working with us this semester, and he's helping with some book quiz question development right now. So that's all.
Yeah, it's a slow going process for me.
He also has the wine lab nearby, which I think a lot of the class meetings.
Little wine bar.
Wine, yeah.
But
Yeah.
yeah.
Yeah, pretty cool.
Yeah, a little wine bar. It's cool.
That's a cool spot. So check it out if you haven't. I also, the other day, about a week or two ago, I finally took my Part 107 test and passed. So
You sound surprised.
Where'd you take it at?
I was pleasantly surprised how straightforward it was. I think the things that I was most concerned with, like, directions of entry for airports and certain things like that, there really weren't many questions.
Yeah, just one or two or so, right?
Yeah. It wasn't too crazy. And I also learned in my drone workshop that they slip in a lot of questions about 10% questions that don't actually count towards your score. They're kind of like, what would you call that?
Test questions?
Yeah, I guess, test questions or something like that, just to see. So that was cool. Got an 87. Waiting for my card in the mail. I finally got my
Your card yet?
No, and I asked advisor or whatever. He was like one of the first people to take it. Took the first date I was offered. And he's like, it takes like 4 months to get a card.
Yeah.
For sure.
Yeah. So
Did you take it at the airport right over here?
I actually took mine in Chesapeake, Virginia, at the maintenance school of. I think I ended up paying $165 instead of $150, but it's not the end of the world. So.
Jim, did you do yours at the airport?
yeah, I did one here.
Okay.
Yeah, it was really easy.
I would imagine the test, they just facilitate it. But anyways, finally made headway getting my thesis proposal finalized. I'm sort of waiting on some feedback from my advisor and I'm going to get that out to the committee. I also printed that newest ortho image, Tom, that we talked about. Have that in a roll in Lisa's lab there so we can look at that. And definitely I'll get more into some of my goals for the semester in terms of Pix4D and all. I wanted to do a quick update on the alumni mapping project. I've inquired with Ginny Reitnauer, who's the director of chapter relations, who's supposed to be our data person, who's going to get us some non-anonymized data so we could actually figure out locations of alumni strategically and geospatially for the alumni relations department. Haven't heard anything from her. So I sent her an email once in July and I sent her a follow-up in August. Still haven't heard anything. I don't know, over the summer maybe there's not much going on, but I figure we still have all that data they gave us and we can make some cool choropleth maps with political districts and counties, like we kind of discussed that day, that I don't think requires actual address points.
Okay.
We have zip code, so that should be enough for that.
Yeah.
And I think maybe if we could design a web app or map, with different layers to show different things, that would kind of be nice to centralize it. I'm not sure. Tom, you said you touched base with Seth Peary, is that right?
Yeah, we exchanged some emails. We never did get a chance to talk about it, so I'll put that back on my to-do list to get a hold of him again.
Okay, all right.
He did last time and didn't get me back, so I'll reach out to him.
Okay, all right. Just to make sure we're following all the rules and everything.
Right.
In terms of licenses. So fall 2019, I'm only taking one physical class this semester and the rest working on my thesis. And that is Yang Xiao's Advanced Modeling Land Cover Change class. So I'm excited to take that and to learn some new things to apply towards my thesis, which is focused on studying changing land cover in southern Appalachian grass bald. In terms of my research, I've got a couple goals here. I'd like to obviously consolidate all the imagery I can find, all the historical imagery I can find on White Top Mountain further. Molly, I'd like to talk to you a little bit about what you were saying earlier. I just slipped this in here about downloading from FTP sites the way you did. I know that VGen has a huge FTP database, and that might help me to navigate that a little more smoothly.
Is that for the LiDAR data?
I believe they have the LiDAR data on the
Pebbles. Sorry.
They have the data on the database, but they also have historical imagery.
Okay, I know Diana, she is starting as a master's student, and I've been working on her with the project, and I think she actually figured out how to use VGen and download it off of VGen using that.
Oh, really? Oh, cool.
Yeah, I'll message her and then send you her contact info.
Great, I appreciate that.
Yeah, no problem. And if it's not the same thing that you're looking for, then I'd be willing to sit down and look at it too.
So it shouldn't take too long, I wouldn't think. I appreciate it. So yes, this fall, I'd like to do a couple more data collection runs up at White Top. Maybe one before leaf off and one after, just to give us a couple different perspectives on phenology up there. Let's see how the data is different. My project's kind of got a lot of small mini projects within it. So I guess as I go forward to kind of suss out some of that and simplify what exactly the thesis is going to focus on. Obviously the proposal's due soon, but I think there's time for all that. Just kind of narrowing it down. You probably could do a project on, analyzing that data before and after leaf off as an individual project, right? But that could be a paper in itself, who knows? I know CDAG is in Wilmington, North Carolina this year, and I've kind of thought about presenting a poster there just to stay up on my conference presentations. So I don't know if any of you all plan to go to CDAG this year, but we could.
What's CDAG?
Southeastern Division of the AAG, American Association of Geologists.
I may have spelled it wrong. I think I missed an A or something, but cool. So there's that, and I think I'll have to look at. Isn't that usually around Thanksgiving, something like that? I know the deadline's in October for submissions. So cool. So yes, this semester I'd also like to get more familiar with Pix4D and Cloud Compare. I saw that comprehensive manual you posted, Tom.
Oh yeah,
onto Slack for Pix4D, so that looked pretty useful. And I've also started to develop the structure for my actual master's thesis, the format for the paper. So I'd like to get my committee's feedback on that at some point and go from there. Right now, I'm kind of juggling some TA duties, a couple hours for World Regions and John Boyer's class, and some for Lisa Kennedy's Intro Physical Geography. So there's a lot of work there, but I think as we get through these next few weeks, the workload should get a little bit lighter for the TA duties. So for next week, I'd like to have all these, I'd like to get my proposal back from my advisor, get it out to the committee, establish a time for our committee meeting, and submit the proposal to the department. Also continuing to build, as Jim is aware, building these question banks for John Boyer's new book. So that's kind of a rush thing. The edition was just published, and we have to have all the book quizzes out by next week. So we're working to develop probably a couple thousand questions for all these chapters. So there's that. But yeah, I'm also working on Lisa's course, putting a couple hours in there, trying to sort of get some new activities going forward. Tim Baird has this really cool initiative called Pink Time. It's based off a book called by Daniel Pink, where instead of coming to class one day, and instead of having an in-class lecture, everyone skips class, right? And goes out and does an activity related to the coursework and the mission of the class, and then comes back and presents on it and get feedback from other students. So we're going to try to integrate that into the physical geography course.
Wow, that's spreading to other classes. That's cool. Yeah, because I took his course, his sustainability course in undergrad. It was very meaningful.
And you had a good experience at the Pink Time?
I did, for sure, yeah. So,
Tim's one of the faculty members in the department, teaches sustainability. He's got a research interest in Africa.
yeah, it's like he has 2 sustainability classes. He has like a environmental conservation class and a like Africa class. Yeah.
He's off on research leave all year, but you get a chance to meet him next year.
Really cool guy, for sure. One of my favorite professors in undergrad. So.
Sweet. My computer here just said battery low. I don't know why it's plugged in, so if it dies, I think I'm almost done with these slides, so it'll be good. Oh yeah, that was it.
Cool. All right.
Sweet.
Thanks, Riley.
No problem.
Charlie, do you want to give a quick update?
Yeah, I was actually about to say that I'm trying to learn Pix4D as well as Adusoft, and I think we were talking about earlier, like maybe comparing the results of the Adusoft with Pix4D, and that might be an interesting way to assess, you know, the strengths and weaknesses of both the software. So, yeah.
Yeah, I think a lot of people would be interested in that. You know, thinking down the road, something like so OGIS is the sort of a confederation of people that do GIS-related work all over campus, and you know, as a poster or something, like I bet a ton of people would love to see a real comparison, because we all know 1 or 2, and we don't know enough about how they really stack up. So.
Right. Yeah, and then I think a good part of my research is going to be comparing SFM structure for motion to the LiDAR data and see how we can get biological indicators from both and see the strengths and weaknesses of both. So I think that'll probably be a good component of my thesis. So.
If you're interested in the, because we had talked about repetition of structure for motion scans, so the 20 scans that I did, and I actually have a few more from, so that's all in one platform, and I've got a few more from the Mavic platform.
Mm-hmm.
To just sort of do an analysis to sort of see like how much, because I didn't look at the vegetation at all. I only cared about the tilts, and that's it.
Right.
But you could start to look and see, like, did the vegetation come out differently in these different scans, just to kind of get a sense of permanence.
Right.
The idea there is, if you're making measurements that are derived from those scans, and you run a scan one day and you go back and you fly it again the next day, how much variability is there in the metrics that are derived from those clouds? Like, you'd hope that they would be the same, but they're probably not. Is it enough to make?
Is it significant?
Is it significant?
Yeah.
Right. So getting a handle on that would be helppful.
Yeah. And then updates for me. I just spent most of my summer doing field work out in Streamlab, which is a outdoor research area that my advisor runs. Basically, it's a mile west of campus, where we do all sorts of like hydrological studies, as well as like where we fly the drone out there and whatnot. So I got to get my hands dirty a little bit, which is fun. Doing a lot of data collection from like the little sensors in our groundwater wells that one of my other students in my department uses, as well as calibrating like YSI sensors, so we get like water quality, continuous water quality data from the stream itself. So yeah, that was a good chunk of my summer, was collecting data, also putting in new sensors, pulling out old sensors, stuff like that. So.
Do you guys ever do like field trips or something out there?
We do, yeah.
I'd love to see it.
Cully does have all sorts of.
Bombing there.
Cully always has people like students or faculty come out there and like get a sense of what's going on out in Streamlab, because it is very interdisciplinary. We have researchers from all over campus doing different studies. Like some people do some bird studies out there, and then we have like some people looking at the invasive species that are prevalent in Streamlab and trying to figure out how to get rid of those. All sorts of different things. So yeah.
Cool. Very good.
Definitely room for a lot of different collaboration between different departments. So that's really cool about Streamlab. Yeah.
Cool.
Yeah, I'd definitely like to hear more about that. That's cool.
Oh yeah, for sure. There's a website that you can check out. I think it's just, if you search Streamlab at Virginia Tech, it'll pop up. So
Cool,
Nice.
will do.
yeah.
All right. With that, I think we'll wrap up the lab meeting portion. Take a little bit of a break, and we'll come back in, I don't know, 10 minutes or so for the orientation piece. All right. Thanks, everybody.
Got it. So Tom, for this, I know I'm obviously not there for the orientation, but will we be getting separate keys for this room here, or will this stay?
Yeah, separate keys. So Karen, you should be able to talk to Karen Bland, and she'll hook you up with a key.
Okay. All right. Thank you.
She look at here.
What's that?
Is she located
Oh
in
yeah,
this
that's the
building?
main secretary, the
Okay.
office manager. Yeah,
Okay.
so if you haven't gotten your keys yet, you probably will. Did you get one already?
I was gonna do that real quick right now.
Yeah, yeah.
On break.
Yeah, might as well.
So do I need to go back and ask for a key for this room specifically, or what?
I think so. They were sort of sorting things out still. The things aren't done. So if it's not ready yet today, you can ask her.
Yeah.
She may not be ready for that yet today, but it will be within the next couple of days. So you can feel free to ask her. Stop by and say, "Can I get a key to 237A?"
Yeah.
All right, you guys back in 10.
So the orientation is just like a resources available.
Yeah, stick around if you can, because if there's stuff that I miss, then you can kind of fill in some of the gaps.
I told my work I'd be back in after this meeting.
Okay.
So I was gonna run back there and finish working.
Okay. Yeah, that's fine. I'll post it anyway. So.
Okay. You guys should record it and post it on.
Yeah, I think so. Yeah, I definitely was going to post the slides. I may or may not post the video, but I can.
All right. Cool deal.
Yep.
Yep. Awesome. Regards.
Slides. Sorry.
Go ahead.
What's up, Riley?
Oh no, I was just you're gonna post slides from the orientation. You said.
Yep.
Okay. Okay. Awesome. All right. Well, I'm sorry I'm not there. I got sidetracked this morning.
No, that's all right. All right. Cool. All right. We'll see.
All right.
Bye.
Sign off.
I'm gonna head out. See ya.
I'll be in
Bye.
an hour.
Bye.
All right. Bye.
Cats in the sink.
Yeah.